Hello, everybody. Welcome to the class. Dr. O here. Today I'm going to talk about the cost of production. This chapter is introductory of producer theory. So far we learned about introduction to the microeconomics under the topic. Um, we discussed about the markets. In the market, the outcome is the most efficient solutions. So market is the best system so far to make our economy going efficiently. But there is a lot of market failure happens, some cases under the externalities or some other cases, the property of goods is a little bit different. So all the considerations is setting up with demand and supply model, which is a market. In that case, is equilibrium determined. The efficient solution is coming out. Market fails, that system or that result is hurt by the fact that the market is not working properly. Now we are going to think about the producers. The main idea of producer theory is that producers are trying to maximizing their profit. Their purpose, their objective is maximizing profit. In other words, making the money. They are focusing on making money. So that money can be redefined with the economic jargon as a profit. Under that, each one of the firm or company or producers, under the sense of maximizing the profit, they are trying to handle with a certain variable to achieve their goals. The goal itself is obviously profit, but there is a lot of other variable to making the profit can be the bigger or the most, the best, the highest, outcome is coming out. Under that, what kind of variable they are thinking of it and what kind of situation they are considering, that is mainly focusing on the producer theory. So today, we are thinking about the production function. Well, the function. Mathematically, we know the function. So linear function is y is equal to ax plus b as a general form. So x is independent variable and y is a dependent variable. We're returning to the elementary school level of mathematics. We are defining or explaining about the function as a black box. You're putting in the input and you will get the output. Input as independent variable. All the factors you are considering, that changes, outcome changes. So input you're putting in, output will be correspondingly change. The input is referring to the independent variable, output referring to the dependent variable. In that case, the thing, independent variable, what is the independent variable of a certain function is really important conceptually. So when you think about the production function, what is a production function? And under that function, what can we derive some important feature out of that function to getting another variable or another measure? By using the measure, what can we derive very meaningful outcomes or measures we can drive, right? So that is one thing we need to looking at it today as understanding production function. And by doing so, out of the production function, we can derive marginal product. Marginal product is a measure, and that using the measure, we can get the efficient decision, the optimal decision out of looking at the marginal function compared to other measures or values, and then decide what is the optimum decision we can make. In that perspective, we're looking at the production function first and then derive marginal product and using that, why that is important and what can we do with it. And next thing is cost. Costs have a lot of cost we can think of, and we already learned about opportunity cost. Well, in economics we say cost, then that is always, abbreviate from the opportunity cost. Even though we are not directly measured with a certain cost, and that's, we can say, explicit cost, accounting cost. So looking at the accounting book, you're booking certain numbers while, doing a business, and looking at that book, and we can see directly with the accounting cost. But some costs are implicit. So we're looking at that implicit cost and consider that cost on top of accounting cost. By doing so, we can make proper decision out of it. So first, we're looking at the cost function, how that looks like, and out of them, we can make a certain decision. Under this cost function too, we can derive a certain measure, which is marginal cost, and what can we do with the marginal cost? So marginal product, marginal cost, production function, cost function. So that, what is that and how we can derive, that is the focus on today's lecture. Maybe time permits, we are discussing about short run and long run. So the cost itself is changing with short run and long run. Well, this is not like very distinct concept. What is short run? What is long run? It depending on the literature and what it depends on the topics too. But when we decide the cost, short run and long run, and when we think about producing process, then short run and long run is usually determined by the availability of inputs. So there is a limitation of deciding certain decision on top of certain variable. So we cannot decide freely to a certain variable. In that case, we define as a short run. Anything else, all the variable we can select that is available, then that is considered as long run. So short run and long run involving the cost itself is different. Short run cost, long run cost, that is differentiate with the time variable as a short and long, but behind the scene of it is availability of input vectors. Well, certainly I derived the input vectors. Well, I need to a little bit of explanation on it. So when we define a cost function, the cost is involving with certain factors. In the production process, we need certain ingredients. Well, in other words, we are saying raw materials. So resources is necessary to produce things. In the short run, certain variable is available and free to change. But certain variable cannot be changed easily. In economics, generally we assume that labor itself is available or easy to change in short run. As time goes by, it can be changed. There is a lot of limitation of changing of the labor. Hiring and firing worker is not the easy thing, as depending on culture and institute. But still, we assume that certain variable is limited by a certain time period, that is short run and long run. The distinction is coming out from direct there. And theoretically, we assume that labor is easily hiring and firing in this case. And capital itself, capital is in the market or producing process, we believe that capital is not like a financial, money or investment, but like a real capital. In this case, real means like machines. So availability, the machine itself, the capital itself is depending on the financial availability too. So time, as a time length you are considering is longer, then you can easily borrowing the money and fund and all those things to increasing size of a plant, which is infrastructure of a producing process. But in the short run, it is not easy to manipulate. In that perspective, we assume that labor is available variable in Shonan, but capital is not freely choose in the Shonan. So in that case, Shonan and Nongnan is defined like that, right? We will discuss this in detail sooner or later. And finally, we are discussing, if time permits today, economies of scale. We need to understand economies of scale as, separate concept. As the first thing we need to looking at is scale. So it is a little bit relating issue with the Shonan and long run. In these terms or this consideration is more like a long run perspective. So, for example, let's think about this. You are running a plant right now. Like all the factors, input factor, we're saying input factor means that the materials or the resources you need to produce things, all the things, the necessary to produce output is called input factors. So input factors are, we can say labor is input factor, capital is input factor, maybe some land is necessary in the agriculture, sector, then land is input factor too, and raw materials to making a certain product. That all those small things are necessary in the process of producing, but in the sense of making a production function, then it is really difficult or complicated to putting in all the variable at once. So in general, in mathematical models, in economics, we representative as the variable for production function is labor and capital. As long as you are considering two variable function, then the expandability of multivariable is easy. One variable is a little bit difficult to expand it because that one variable function is not considering at all about the relationship between independent variable. So for example, we say labor and capital is input factors of a production function. We are not gonna looking at that production function at these levels, but once you building up the two variable function as the starting point of the multivariable function, the relationship between labor and capital as a independent variable you considering and relativity of that controls, that technique can be easily applied to the multivariables. Like all production process, there is a lot of variable involving, which means input factor is necessary in reality, but we just assume that 2 is enough to expand to the multivariable case once you building up the analysis tool for two variable case. But in this class, we're not going to do it, just we are assuming easy form or comfortable functional form as a labor, as a production process, only input factors. And we can do that as considering other variables are all equal. We assume that. In other words, ceteris paribus assumption in Latin phrase, we're using a lot in economics. So other things are all equal. We are only changing, we are considering only change of the labor amount, putting in as input factor, and production amount or quantity of product can be changed correspondingly. But yeah, under the sense, scales. Scale means all the input factor is carbon copied in multiple scales, like a double, triple, quadruples, and furthermore. So under that cases, as long as input factors are doubled, then how much about the output increases? So as long as input factor is doubled, like a labor and capital or whatever it is doubled, corresponding output is exactly double. That is called constant returns to scale. What does that mean? Is the scale of input factors or production, the production process itself is doubled. Then output is exactly doubled. Constant return itself. Input increases, output is correspondingly increases as a scale of all the inputs together. So that is meaning of scales. Economies of scale means that increasing returns to scale. Scale increases, return is increases. In other words, we are calling it economies of scale, which is you doubled all the inputs, but output is more than double you can get. Opposite case, this economies of scale. So even though you doubled all the inputs, but your outcome is less than double. So that's not profitable. That's not profitable for your side. So that cases can be called diseconomies of scale. So yeah, that kind of concept will be discussed very end of this chapter. So today we are going through first production function and cost function. That out of it some concepts. Using that concept, what can you do? Is mainly we'll discuss today. First thing we need to consider today is profit. Producer theory, the objective is maximizing the profit. So each one of the firm try to maximizing their own profit. Well, what is profit? How we can get it? So maximizing profit is goal for each firm. Then we need to define the profit first. Profit is what? Well, profit is defined as total revenue minus total cost. What is the total revenue? Total revenue can be defined as how much money you can make by selling your product. So you produce your things, your product, goods and services. Yeah, you are running a business. You are running a company or a firm, producing things. Simply you produce certain amount of output or goods, product, certain quantity of product. Then, what do you produce? Why you produce? You produce is to sell it and make money, make a profit. But once you calculate the profit, first the thing is, oh yeah, how much money you can make by selling your sales, right? So only you produce outputs and then you sell it in the market. How we can get the money, how much money you can make? So simply speaking, the amount of your quantity you sell times of the price you charge. Competitive market, the price is given by market equilibrium. So each individual firm doesn't have any power to change it. So we accept P as a given. Price is coming out from the market. And then that price times how many quantity of product you produce, multiply it by them together, then you can measure the total revenue, total money you can make in the market by selling your product. That's total revenue. And what is total cost? Well, you are in the process of producing under the producing process, and it is always involving the cost, right? Yeah, input factor we can consider. Once you try to produce things, you need something in the process. You're putting in the labor and capital and whatever, land, and all those things need cost. You need to pay a certain amount of money to running the business. That's nothing but cost. So the money you made in the market is total revenue, and the money you need to pay to involving with the production process, then that's total cost. Total revenue minus total cost, you make money of production process. Real money you made, like a sales and your cost. So total revenue minus total cost is profit. So in simply speaking, in the equation form, pi is equal to TR minus TC, total revenue minus total cost. Why pi? Profit start with the P, yeah, but P is already captured by the price. So in the market theory, right, equilibrium price P. So P is already captured. So we want to use in P as initial, as a variable, but already captured. So we are trying to get the Greek letter. So this pi is widely used. In mathematics, pi is the ratio of circles, right? So 3.14 like that, right? That is not the case in this, in our sections. In our class, pi means profit. So profit is total revenue minus total cost. Now let's talk about cost. Well, cost can be measured in all different, perspective. But one thing we need to think about is explicit and implicit cost. Explicit cost is, visible and easily calculable, but implicit cost is hidden in many cases, so hard to see. How we can interpret implicit cost and how we can find it? Well, explicit cost, yeah, that is accounting cost. It's in the booking. So certain money you paid to buying some raw materials, that's easy to measure it. But implicit cost is already hidden, so it's hard to detect. Well, it is really, relating issue with opportunity cost. Accounting cost, opportunity cost? Well, we'll see in certain examples. So here is the example. Well, assume that you are going to running the business, but you need $100,000. Then you don't have any money right now, so you want to borrow $100,000 from the bank. Well, $100,000 from the bank will another additional cost is involving. Well, let's say that 5% per year. So annual interest rate is 5%. So each year, end of each year, you need to pay 5% of $100,000, which is $5,000. So in this case, the cost is $5,000. Easy to calculate? Yeah, explicit cost. But let's think about these cases. This scenario. You have $40,000. So 40% of $100,000 you already have in your pocket. You already saving it for some reason, and then you have it. Now, if you want to running a business, yeah, I have $40,000, and I only borrow $60,000 and running the business. My cost is reducing in that perspective, right? Then $100,000, $5,000 as a cost per year. But in this case, $60,000, 5% is $3,000. Well, yeah, the cost is reducing. In this case, explicit cost is $3,000, but you ignore your own money. $40,000 doesn't involving any cost. Well, is it true? What can you do $40,000? If 5% is market equilibrium interest rate, then you're putting in the bank $40,000. Well, borrowing and lending rate is different, but still there is interest forgotten cost. You're putting in the $40,000 in the bank, and then you will make a 5% per year. Well, it's a different, borrow lending, I admit it, but somewhere else you can putting in the stock market or some other financial product, and you can make even more than 5% of it. Then your opportunity cost of $40,000 in your pocket, and you are using it in your business, doesn't involving any cost. No or yes? Yes, it does. It does have opportunity cost. Well, fairly we can setting up, and simply you can setting up at 5% annual rate is a market equilibrium. Then under the $48,000 in your pocket, also you forgot interest, which is $2,000. $2,000 plus $60,000 of interest at $3,000, which is $5,000. It's the same as $100, 100,000 of your original investment money. Exactly the same. So what does that mean? $2,000 of cost of your using your own money, that opportunity cost is implicit cost you are not considering. But on top of your measured implicit cost at the same time, or correspondingly correctly implying it, then your cost of $100,000 project is nothing but $5,000 as the same, borrowing from the bank, using some portion from your pocket, it's the same thing. So we are considering opportunity cost correctly, that make correct decision all the time. So implicit cost, we need to keep an eye on it. We need to be careful about, looking at and finding out the implicit cost. By doing so, you can make correct decision. Let me change to the cost perspective, right? Accounting cost and opportunity cost. Accounting cost is booking and easily detecting. Yeah, explicit cost. Opportunity cost, implicit cost, put them together. By doing so, we can measure direct, original, good opportunity cost. Right? So in economics, we are considering opportunity cost. We say cost. That means, opportunity is abbreviate. You understand that way? Easily you can say it. So accounting cost plus implicit cost together, by doing so, we can measure correct cost in the economics. So that is opportunity cost. In the a little bit different, angle, we can say the profit, accounting profit, total revenue minus accounting or explicit cost. So in the book, you can see your profit, but you are not considering implicit cost, then you always over evaluate your accounting profit. So your profit can be measured higher than it should be. So always you need to apply, economic profit as total revenue minus total cost, which is, perspective of opportunity cost, including implicit cost. So accounting cost and additionally, you need to think about implicit cost additionally. That's necessary. Now I think we are ready for introducing production function. So I briefly explain about the function, and I borrowing some idea from the elementary school math. Well, function, right? Function can be several form, and production function can be presented in different method. Well, mathematical equation can be represent a production function, and we can show it the form of a table or graph even. Well, so we are more stick to, graphical or table presentation today. So what is a production function anyway? Well, functional form, yeah, we show the relationship, usually causal relationship, cause and effect. So we always saying independent variable affect to the change of dependent variable. Under the case, then what is the production function? Well, production function is a relationship between input vector to quantity of product, quantity of output. So usually input vector can be so many variables, but it is so complicated. In reality, that's a lot. But let's say today we're focusing on only one variable. So production function as one variable function. In that cases, we assume that all other things are equal, but we change the labor and the quantity of output can be changed by changing of labor. So we are introducing production function. The quantity of output is dependent variable, can be affected by the change of labor amount. So the independent variable is L, labor. Dependent variable is quantity of output, which is Q, So that is the production function. So in general, as I told you, we expanded to the intermediate level of production function. Production function, quantity of output is a function of K and L. Well, K is a capital, L is a labor, and some other factors are all equal. Well, yeah, and there can be all other variables. For example, land can be need a land to product the production facility can be located, and capital machines or tables, computers, all those facility to making a product, and labor, working hour, somebody who is working there and then you know making or producing the outputs. So there is a lot of other input factors, but we are focusing on labor today. And in that perspective, production function is labor as independent variable, and quantity of product or output is as a Q is the dependent variable. So L is increases, quantity of output will increases. Obviously, intuitively, you can understand that. And then that production function can be shown as mathematical explicit functional form, but today I'm introducing to you that the presentation of table or graph as production function. So here is the example. Farmer Jack's production function. Farmer Jack grows wheat. He has 5 acres of land. He can hire as many, worker. So here is the table and graphics. Well, let's look at the table first. L is a labor, right? L can be 0, 1, 2, 3, 4, 5. So number of worker he can hire. 0, hiring worker. Quantity of output is a 0. And he hires 1 labor or worker. Then quantity of output is 1,000. And 2, 3, 4, 5, correspondingly, the number increases, 1,800, 2,400, 2,800, 3,000. And then we plot it, L as, horizontal axis and Q as vertical axis. And as you can see, the dots is showing each one of the lines of table, each rows of tables numbers, 0, 0, 1, 1,000, 2, 1,800, 3, 2,400 correspondingly. The shape of production function right here looks like quadratic functions. Well, yeah, each one point we have information of data set of 1, 2, 3, 4, 5, 6, right, points, and we just connect it with the lines. It doesn't look like a smooth curve, but the slope of each line is decreasing by number of workers increases. So yeah, if it is, there is a lot of more values of number of workers, we can say number of workers is 0.1, 0.2, 0.3 correspondingly, and we have a specific functional form there, then that kind of show numbers as output, then it should look like a quadratic function, the shape itself. Now out of this production function, we find one good measure to making efficient or correct decision. So really important concept from the production function is marginal product. The concept of marginal, in other words, additional. Explanation of marginal can be explained with additional. Additional, one more unit of input increases how many output can be changed, can be measured, or can be explained by the marginal. So we are looking at the marginal product. Marginal product is quantity changes, corresponding change in input factor changes. So one more unit of labor is hiring, how many quantity of output changes correspondingly? That's nothing but marginal product. Well, somebody who is comfortable with the calculus, oh, it is coming out from the derivative. Yeah. In the perspective, easily explained, and then we can measure each one of the point, and that tangent line, the slope, is representing the derivative, and that is nothing but marginal concept. So in English, right, a simple verbal explanation: if Jack cases, Jack hires one more worker, his output rises by the marginal product of labor. So one more unit of labor is hiring, then how much quantity of output changes? That's nothing but marginal product of labor. Additional one more unit of labor changes, output changes. I introduce notation delta. We saw this before in the section of elasticity. What was the original definition of elasticity? Percentage change of Q over percentage change of P. Well, what is percentage change? Percentage change, right? Original value as the denominator and change of the value. Well, percentage change of Q can be defined as delta Q over Q. In other words, delta means change in Q, right? So if the value is changing from the Q1 to Q2, Q2 minus Q1, starting point is Q1. So delta Q over Q can be defined as Q2 minus Q1 over Q1. Well, it's the same thing. So in delta means the change in that variable. This delta is coming out from the Greek letter, uppercase delta is like a triangular shape. Yeah, we use in mathematics a lot as the change in, as the name of it, right? So delta Q is change in output, delta P is change in labor. So in other words, marginal product of labor can be defined as delta Q over delta L. So denominator delta L as interpreted as if you hiring one more unit of labor, how much quantity changes can be written in mathematical form, delta Q over delta L, which is marginal product of labor. Now, why marginal product of labor is important? Because it is a really good measure, an important measure to make really important decision. What's that? So we are considering about how hiring how many labor or worker in this case. Jack is thinking about it. Well, he involving this situation, he knows that if he hires one more labor or one more worker, he need to pay wage. Wage is determining the labor market, like equilibrium price. P is coming out from the goods or services market, right? Yeah, in the labor market, it's exactly the same. As a owner of a firm or running a business, you are thinking of hiring one more worker or not. Is one of value you are looking at is the equilibrium price of labor market, which is wage. So you are hiring one more people, you need to additionally pay one more unit of labor, which is wage. If wage is determined as in the market, then wage itself is determined as a given, right? And you looking at the wage. If you hiring one more unit of labor or one more worker, you need to pay additionally per year, per month basis, whatever wage you need to pay. That is your cost. And what is the other thing you need to consider? Then, if I hiring one more worker, what can be changed as a form of outcome? Marginal product of labor is giving me exactly the information that I need as a Jack point of view. That's marginal product of labor. Well, hiring additional unit of worker giving me how many output I can get. At a certain point, marginal product of labor can be changed. But at this moment, should I hire one more unit or not, can giving out the chance that comparing wage to marginal product of labor, and then you decide, will you proceed this hiring process? Well, one more thing you need to consider. What is that? Marginal product of labor is output. Output changes what you can get the benefit. Oh, quantity. Quantity increases will give you the benefit as the change of revenue. Well, revenue can be changes or dependent on the product you can sell. In the cases, yeah, exactly what it is you can consider. It is called value of marginal product. The value of marginal product is price times marginal product of labor, which is marginal product of labor is change of quantity, right? If you hiring one more worker, how many output you can get times price. Then what does that mean? Value of marginal product, which means that dollar value you can earn by hiring one more labor. And then that can be directly compared with wage. If value of marginal product is bigger than wage, you are going forward to hiring the worker process. Yeah, you can get the benefit out of it. Your profit will increases by doing so. What is the purpose of, firm? Maximizing the profit. If profit can be increased, what you should do, you should go for that. In that perspective, yeah, marginal product of labor, looking at it, right? And comparing with the wage, marginal product of labor times P, giving you the corresponding value relative to the wage. And then you can make exact point of profit maximizing labor you can get. So in the process, marginal product of labor will giving us that or the most efficient or important information to make a best decision out there. So when we're looking at the production function and the graphical presentation, the shape looks like inverted U-shape quadratic form. In other words, what does that mean? That means that diminishing marginal product. Diminishing marginal product of labor. Well, in that case is horizontal axis was labor and vertical axis is output. In that cases, additional hiring one more unit of labor, the output increment is a decreasing rate. If it is a linear shape, then it is constant. But in this case, inverted U shape, that means that the slope or increment, each one of the slope of lines, connecting the, two dots is a decreasing, right? Increasing rate, it is increasing function, but decreasing rate. The slope of each one of the range is decreasing by, so that is reflecting diminishing marginal product of labor. Is it natural? Yeah, that's a natural tendency in reality. And why is that happen? Well, that's because we are looking at the one variable changes out of the assumption that everything else is equal. So the amount of land, in this case, land and labor is only two factors we are considering. Land is already, Jack already owns it, and he just increasing number of labors, and then product is increasing by doing so. But land is limited and keep hiring more people, thus increasing more and more value of output. Then what will happen? He will keep increasing indefinitely. By doing so, his profit will increase. Marginal product of labor is not diminishing and increasing, then he cannot stop it. So the size of his labor hiring is infinitely many. We cannot find optimum solution. So mathematically, realistically, not a good point of it or good example of it. But in general, it is happening. Like other things are all limited and equal. Like a number of computer is setting up in the factories or plant, and hiring more and more people will making output increases. It's not like probable happening in general. So generally, other input factor are limited, and hiring or implying more and more one input factor doesn't change or doesn't speed up of marginal product. That's realistic explanation of it. So some range it can be possible, like there is a two worker in a certain factory instead of one, will improving the outputs. Well, that is originally coming out from the Adam Smith's Wealth of Nations specializations of production process will boosting the marginal product of labor. But in general, in certain range, it is happening. But once it is a certain level, then general tendency is diminishing marginal product. So yeah, in that case, is the shape of quadratic function or smooth lines increasing like a rate is like this. So as the shape of quadratic function, u shape of quadratic function can be shown in the certain range, or as time goes by or number of labor is hiring more and more, then invert to u shape of curvy quadratic function shape is happening. So in other words, marginal product of labor is diminishing. In the beginning, it cannot be the case, but eventually we can observe that case. Now let's look at the cost of function. So we are returning to the farmer Jack's farm. He owned the land, but we know, and we already learned about opportunity cost, implicit cost, right? His land opportunity cost is $1,000 per month. So instead of he owns it, right? He borrowing or lending certain amount of farming area, monthly cost is $1,000. Or someone is offered that, yeah, that if Jack borrowing someone else, he would pay $1,000 per month. So monthly payment of that rent is $1,000. So in the cost perspective, even though he is hiring no worker and production of that farm is zero, we're looking at the LQ side of table at the production function, and L is 0, Q is 0. There is no worker, output is 0. But yeah, cost of land is necessary to pay as $1,000. Opportunity cost is $1,000 per month. And that cost doesn't disappear, and that cost doesn't increasing by hiring more workers. Get it? So the cost of land not changing by L changes. So independent with the L changes. So cost of land is $1,000 fixed. In that perspective, cost of land is a fixed cost. And as we can see, L increases, the TC increases. Oh, before that, cost of labor increases. Well, that is changing by increasing by 2,000, which is equilibrium wage is $2,000 for farm worker monthly. So L is 1, 2,000, L is 2, 4,000, L is 3, 6,000 correspondingly. So cost function is composed with these factors. Fixed cost $1,000, whatever you hiring L levels, and the cost of labor is correspondingly 1, 2,000, 2, 4,000, 3, 6,000, like that. And then total cost, aggregate, fixed cost as the cost of land and cost of labor as a variable cost. So even though you are not producing, you need to pay $1,000 total cost, and labor is 1, yeah, $1,000 plus $2,000. Like, one farm worker wage is $2,000, right? So 3,000, and total cost is composed with 1,000, 3,000, 5,000, 7,000 to the 11,000 correspondingly. There's no problem to understand this table, and we can move on to Q and total cost, and this is total cost function. So total cost function, what is the independent variable? This is we can see the horizontal variable, which is a quantity of width. So Q is independent variable. If you change your mind how many quantity you want to produce, by doing so, the cost is changing. So total cost is changing. Well, it's a kind of mirror image of production function, because the land cost is fixed as a line, it's a constant, and 1,000, it's a fixed. And production function itself is inverted U-shape. When we're looking at it now, it's U-shape of cost function, total cost. So yeah, it is exactly the same logic to build up. The green color dot is already, marked with all the numbers, 0, 1,000, 1,800, 2,400, 2,800, 3,000, correspondingly, and you dotted total cost as 1,000, 3,000, 5,000 to 11,000, and linearly connected it. And if it is not like we observe a certain data point at this point, but it is continuously, we can observe all the measures of quantities, then we can plot it with certain shape or smooth curve. Because it is originally built up with a certain functional form, I didn't look at or calculate the form of it, but yeah, it is originally coming out from the functional form, that's why. But it is more like a theoretical background, but still does have implication to the reality. Now, marginal cost. So we learned about the marginal product already. So marginal cost can be calculated with delta TC over delta C, right? As a corresponding, marginal product of labor cases, one more unit of labor, how much quantity changes? In this case, total cost, and the marginal cost is the independent variable is Q. So one more unit of Q producing, involving how many cost changes. So that is nothing but marginal cost. Well, the one thing different is, MC is located in the middle of TC, each one of the TC involving. So quantity is 0 to 1,000. It changes 1,000 to the 3,000. How we can calculate it? 3,000 minus 1,000 is 2,000 over 1,000, right? And that's 2. So that's nothing but the change of Q, change of TC over change of Q. 0 to 1,000 changes 1,000. 1,000 to the 3,000, so 2,000. 2,000 over 1,000 is nothing but 2. But why MC is in the middle? Well, it is originally coming out from the discrepancy of this discrete variable relative to the continuous variable. If it is a continuous variable, we can measure it with the, calculate the derivative at a certain point. But this one is a big gap of variable change. Like denominator Q changes is 1,000. The next one is 800. It's a really big change. It's not a small decimal change. Derivative is denominator amount is going to almost 0. So small decimal change measured by how much dependent variable change. By doing so, tangent point, the slope of tangent line can be measured as derivative at the point. So it can be measured like that, but this one is Q changes is jumping from the 0 to 1,000 to 1,000 to 1,800, like that. So in that case is, measuring from the one point to another point is a way different. So we want to average out of it. So in the middle of it, we measure it. So that's how MC is located in the middle of two rows in Q and TC cases. Well, discrete and continuous discrepancy or functional form itself is those kind of, error is always happens. But that is not the big or important point or concept right here. So let me skip that. So MC can be calculated with the delta TC over delta Q, as you can understand, or we already discussed about in the calculation of marginal product of labor. Now let's think about the why MC is important. So each one of the producers try to maximizing his her profit. Under the calculation of profit maximization, what is necessary? Well, profit is measured by, or the measured by total revenue minus total cost. Pi is equal to TR minus TC, remember? So under that cases, looking at the pie, we want to make a pie as big as possible. But let's make a decision as marginal point of view. So to getting the optimum point, what you need to do? Let's starting to think about this. So in that cases, pi profit function is function of Q. Total revenue can be measured or depending on how many quantity you want to produce. And total cost also function of Q, as we can see the cost function. In that cases, if you want to decide exact point of Q to maximizing the profit, that's what we are going to looking at it. So starting from the 1, 0, 1, 2, 3, 4 correspondingly, or 1,000, 100, 1,800 correspondingly, output we can be measured by looking at how many quantity changes correspondingly. In that process, the cost function shows us in that concept, cost function can be changed to marginal cost. Under that, we can think of this. Well, how about revenue changes? Well, under the competitive market, price is given from the market. Market equilibrium price cannot be changed by each one of the firm. So many buyers, so many sellers, so many producers, so many consumers participating in the market. So nobody has the power to change equilibrium price. So price is given from the market. Once we aggregate all the individual demand, individual supply, and then at the market, the force meets an equilibrium determined, and the price, equilibrium price is coming up from there. Then we accept it. As long as we want to sell a certain amount of our product, then in exactly the price market show, then we can sell it as many as we want. That means what? P is given, P is constant. So total revenue is P times Q, right? So P times Q, and each one of Q changes. Additional Q you are going to more produce. That's how we can calculate the marginal cost. Exactly the same thing. Marginal revenue is nothing but price. So one more unit of Q you want to produce more, then how many dollars you can earn from that activity, then movement, then that is nothing but P. P is nothing but marginal revenue. So what is that important of explanation? Well, marginal cost, you can calculate it and you compare with the equilibrium price. Equilibrium price is higher than marginal cost, then you will produce more. What does that mean? Additional one more output will give you more profit increment. So you're producing one more. And at that point, a marginal cost is less than price, you go for it more. Until when? Marginal cost is equal to price. At that point, your profit can be maximized. So every decision in the optimization process is determined at the margin. So you're looking at the one more unit changes, and then that gives equalize with the comparable value. That is the optimum point. after that, that is turnover. So after that, it is equalized with the price and the marginal cost. And then you try to produce more than marginal cost is bigger than price, because marginal cost is increasing as quantity increased. So yeah, we will see about this kind of concept a little bit more in detail later. But this process, why marginal cost is important, because it gives us very important information to make us to deliver profit maximization. So in the process that we compare with the marginal cost to marginal revenue, in other words, competitive market price. So price and marginal cost, you compare, price is bigger, you producing more and more. Quantity will be increased. By doing so, you can increase your profit. Until when? Price is equal to marginal cost. Profit max condition is nothing but P is equal to marginal cost. So today I introduce a production function and cost function. And under that, we consider that the marginal product of labor and the marginal cost. So marginal concept is really important because we can make optimal decision by comparing with those measure relative to the other value. So in the labor, how much labor we are going to hiring relative to the marginal product of labor, we compare with the wage. So in that case is how much labor we need to employ. That is a determined optimum level of labor we are going to employ, determined by comparing with the wage. And we're looking at the cost function and deriving marginal cost. Marginal cost is really important in the process of profit maximizing process. So before that, we reviewing a little bit about implicit and explicit costs. In other words, we need to understand opportunity cost. In economics, we are going to consider all the time, and we refer in cost, we abbreviate opportunity cost in that cases. So that's all today's summaries, and this is a really important concept to think about, or to understand the total, producer theory. And our topic is, or the objective of producers are always profit maximization. So today's topic is the cost of production, but under that cost function, production function is really key to understand this total, lines of it. This foundation will help us to understand producers' behavior in the market and in general. I hope you understand well and enjoy the class, and have a nice weekdays, and see you soon.